topic of my final project is rendering a black hole in OpenGL. A black hole is a celestial body with numerous gravity that even light can't escape from it. Here is the structure of a black hole. In order to render it in OpenGL, most structures in this picture will be simulated in shaders. This is a black hole gargantua in the movie Interstellar. In order to render the complex light effect around a black hole, we need to simulate the blending of lights, which means making the photons be attracted by the black hole. In order to realize it, here comes the core technique in my project, ray marching. Ray marching is basically a technique that simulates a ray from the camera and directs to every pixel on the screen. The color of the pixel is decided by the color that its ray heat. In that case, we can trace each ray and even bend them. Here's a great video that shows the detail of ray marching. So firstly, it transforms the coordinate of the inner plane of camera's projection into the world coordinate to get the screen plane. Then it starts to fire rays from the camera and check the heat color of the ray and return it to the screen pixel. So finally, it repeats this process on each pixel of the screen, then get the final picture. In my project, firstly, I render the scene into a frame buffer that use a fragment shader based on then I use the fragment shader based on this frame buffer to create a black hole. The picture on the right side here is that shows what's inside the frame buffer, just two planets with a skybox texture. The skybox is realized by cube texture in OpenGL. I will not introduce it in detail here. And anyway, then in the frame buffer's fragment shader, I transfer its texture coordinate from range 0 to 1 to -1 to 1, which make it can be transferred into world space. Then I transferred it into world space by multiply it by the inverse projection and view matrix of the camera. Finally, I divided the XYZ component by the homogeneous coordinate to the W component to get the position under the world space in the form of vector 3. Then I can shoot a ray from the camera to the position to realize the ray marching. The most important feature of a black hole is that it bends lights to form a gravity lens. Following the physics law and relativity, here's a formula that how the photons accelerate to the black hole. After these calculations, I can get a final heat color of the bent ray on my frame buffer. Then I can transfer it back to the texture coordinate to show the final color on the screen. And here is the ring, and here you can see the ring and twisted effect is actually the gravity lens. The next part is photon sphere. This is actually those luminous photons on the edge of a black hole's horizon. I used this formula on the top right here to create a light around the black hole itself. And here comes the accretion disk. I realize it with the sign distance field, which is SDF. This function can help me to track the edge of the black hole and create a simulated accretion disk effect. Then I use a noise texture to make the simulated accretion disk more realistic. Finally comes the relativistic jet. This is much easier because it's actually periodically emitted high-speed particles around the black hole, and I just stimulate it by a light column with a gradient of colors. And the proximal part is blue because of the high energy, and the distal part is red because of the low energy. But the blue part here is too bright, that close to white anyway. And here's the final render result of my black hole.